you have studied in the advanced level, right? Let's see from that point onward how you can get more and more knowledge so that you can think about complex symmetric titration. Okay, right. So let's see. Go to the next. Go to the slide number 1 here. The slide. So you can see the complex symmetric titration. Likewise, in any other titration methods so far we have studied, acid-base titration and precipitation titration. The name of the titration itself tells you what sort of reactions are taking place in the reaction, right? In the precipitation reaction, the precipitation reactions are taking place. Likewise, here in acid-base neutralization titration, the reaction happening, that's a neutralization reaction. Here, the titration, where the complexes are formed. That means during the titration, so what is happening there? The reaction is happening, and we get a complex, right? So these methods are called complexometric titrations or complex formation titrations, right? You can call them either complexometric titration or complex formation titration. So the complex formation for the titration, now you know there should be a reagent. Here the reagent is the complex formation reagent, right? You have in the burette complex formation reagent. So this sort of titration, the complex formation, complexometric titrations are very, very widely used for the determination of metal ion concentrations in samples, right? Anyway, what you have to do, if it is a solid sample, you have to extract the metal into a suitable solution and then do the titration, right, with the complex formation reagents. So these reagents, what are these reagents? These reagents are in fact organic compounds. These reagents are in fact organic compounds that contain several electron donor groups. Now you have to understand what we mean by the electron donor groups. So the complex formation titrating reagent or the complex formation reagents are organic compounds. Particularly, they contain several, right? You just look at that. It says several, right? Contain several electron donor groups, right? What are the electron donor groups? What you say the complex formation reagent contain, this is a part of the complex formation reagent, and this, you know, the nitrogen, it's unpaired electrons, right? These are also we call lone pair electrons, right? We call them lone pair electrons. Lone pair electrons, right? They are lonely there. So anyway, they are available to make some sort of bonds with the metal ions, right? So for the complex formation reagent, there should be in the molecule more than one or two or three or four, like that, the electron donor groups, right? And what happened, as I mentioned earlier, they form multiple covalent bonds. They form multiple covalent bonds. If you think about something like this, look at here. What is this? Ethylene diamine, right? This is ethylene diamine, right? And here on this nitrogen also that's a lone pair electrons, right? So with the metal ion, if you have the metal ion here, just put M, can make a bond with this one and this one, like this, right? So like that. So the both the electrons are from the reagent, not from the metal ion, right? So metal ion can accommodate electrons from the donor group, and finally you get a bond formation between that electron donor group and the metal ion, right? The metal ion accommodate electrons there, and then both the electrons of the bonds are covalent bonds. The bonds are covalent bonds. So I have mentioned here the bonds are covalent bonds. That means two electrons are shared. But the important thing, both the electrons come from the reagent, complex formation reagent, right? So right. Then the complex formation reactions, right? The Morse metal ion, it's very important that the Morse metal ion react with electron donors to form coordination compound. The compound, the metal ion compound, thus we get in reaction with metal ion, your reagent, the complex formation reagent react with the metal ion, right? What you get is they are the complexes. They are the complexes, or they are also called coordination compounds. Coordination compounds. And particularly these electron donor groups, you just get to know about this one. The electron donor species are called ligands. Very, very important. Okay, what is a ligand? Then you have to define a ligand, right? So this particular one, this particular thing here, ethylene diamine is a ligand, right? It is a ligand. That means if you want to write the definition for a ligand, you can say ligands. A ligand is, you can see the ligand is, and it can be an ion or a neutral molecule, right? That forms a covalent bond with the cation or neutral metal ion. How it is formed? By donating a pair of electrons, right? I just use L, that's a ligand, and you have the neutral metal atom or charged one, and here you have on the ligand unshared electron, lone pair electrons, and this is how you indicate the bond formation. Right, it is donating both electrons from the ligand to metal. Now the bond is formed. This bond is called coordination bond. right? It is called coordination bond. This is called coordination bond, and also it is called dative bond. Okay, DATIVE. Okay, this particular bond here, it is called either a coordination bond or a dative bond, right? Now, example for a ligand, water molecule here. Water molecule, you can see the water molecule here. It has 2 lone pair electrons there on oxygen, right? So you can expect water molecule to make a bond with metal ion by sharing its lone pair, by donating its lone pair electron. And even ammonia, right? Ammonia, there's 1 lone pair electron. So the thing. These are neutral ligands. These are neutral ligands. Similarly, you can think of ionic ligands, anionic type, chlorine, chloride ion, and it has how many? Like 3, something like that, right? So you can think they also can make coordination bonds with the metal ion. So right. So we then move to the next slide. The next slide. Then it's the coordination number. The coordination number, by definition, it is the number of covalent bonds that the cation tends to form with electron donors, right? So simply, what is the number of coordination bonds a metal ion can form or make with ligands, right? So they make with ligands. Then the like if we can take a very typical value of the coordination number R, can be 2, can be 4, can be 6, right? The coordination number of a metal ion. Actually, here the coordination number always referring to a cation. So the coordination number of a cation, it can be the 2, 4, or 6. One of these, so 2 can be the 2, right? So if we take copper 2 plus cupric has the coordination number of 4, right? That means your copper 2 here, right? It can accommodate 4 ligands here, right? So it can make 4 bonds with ligands. For example, ammonia, another ammonia molecule here, NH2, another ammonia molecule here, and another ammonia molecule here, right? 4 coordination bond, 1, 2, 3, 4 coordination bond, right? The copper, the coordination number, copper 2, the coordination number is very common one. It is 4, right? So with the same metal ion, when it combined with ammonia, right? What you get, the ammonia doesn't carry any charge, right? Here, sorry, NH3, right? It is NH3. ammonia doesn't carry any charge. It is a neutral one. So what is the thought?
Omsakthy then Omsakthy. நான் இப்ப மனிதாக்களை பாக்குறதுக்கு என்ன செய்யறேன் இப்ப இருக்கிற ஒன்றை தான் யூஸ் பண்ணுவோம். இப்ப இருக்கிற அட்ரஸ் ஒன்றை தாங்க எனக்கு என்ன நாளைக்கு நாளாண்டே கல்யாணம் இன்றைக்கு நாளைக்கு கொஞ்சம் கொஞ்சம் போடுவோம். சரி. இந்த பூக்கடையில் விட்ட இடத்துல ஒப்பண்ணாவதான் அதுக்கு சாமிச்சு